Hello, we are Team Beta, FTC Robotics Team 8397. My name is Caitlin.
I'm Christopher.
And I'm Isabella.
Team Beta is the first robotics team, and we are part of the Adirondack Engineer 4-H Club. We are based out of Plattsburgh, New York, and are right in the corner of New York, so that we border both Vermont and Canada. We have a total of 9 members on our team. So what does a robotics team do? Well, we build and program a robot to best complete the year's competition. For example, the main goal of this year's competition is to shoot foam rings into the highest goal you see on the tower to the right-hand side. We then compete with other teams to try to earn a spot at the World Championship in Detroit, Michigan. Team Beta is a very successful team and has earned a spot at the championship for 4 years in a row. Approximately only 1.5% of all teams earn a spot at the championship. Today, we are going to talk about what FIRST is, what we do as a robotics team, how NASA uses robots to explore space and complete certain tasks, how robotics will lead to humans on Mars, and how you can join an FTC team. To begin with, Chris will talk about what FIRST is.
FIRST is a non-for-profit international organization. FIRST stands for Inspiration and Recognition of Science and Technology. FIRST does not only run robotics competitions, but they also teach youth and students many life capabilities, including self-confidence, communication, and leadership. There are 4 different levels of FIRST. There's FIRST LEGO League Junior, FIRST LEGO League, FIRST Tech Challenge, the level Team Beta participates in, and FIRST Robotics Competition. Question: how many FTC teams, FIRST Tech Challenge teams, do you think there are in the world? A, 100, B, 1,000, C, 3,000, or D, 6,000? I'll give you around 20 seconds to come up with an answer. And the answer is D, 6,000. There are actually just over 6,000 FTC teams around the world. Congratulations to everyone who guessed it correctly. Now, Caitlin will talk to you a little bit about our robot.
So let's start by exploring our robot for this year's competition. Every robot needs a base, whether that base is stationary or moving. In our case, our base is moving. As you can see from this video, our robot can move forward, backwards, left, and right without having to turn. It can do this because of our mecanum wheels. Mecanum wheels have rollers placed at about a 45-degree angle that allow our robot to move in any direction. These wheels are attached onto motors that are attached onto base plates, which protect our robot from game elements and other robots in the field. Another aspect of this year's competition is being able to pick up the wobble goal in the right-hand picture and drop them over a 12-inch high wall. To do this, we use an arm powered by a motor with a grabber on the end. We have 3 main positions for our arm. The first one, which is farthest to the left, is our arm in the stored position, which it is in for the majority of the match. The middle picture shows our arm extended and grasping one of the wobble goals. Finally, the picture to the right shows the arm vertically over the wall where the grabber will release the wobble goal, scoring our team points. Now Chris will talk about 2 of the most important mechanisms for this year's competition.
As Caitlin mentioned earlier, one of the most important aspects of this year's competition is scoring the rings in the high goal of the tower. To do this, we use an intake of 3 sets of wheels that pull the rings off the field floor into our robot. Once the rings are inside our robot, there's a kicker that will push them against the shooter wheel and launch them outward, in theory, throwing them into the high goal. This is a video of one of our practice matches from earlier in the season. We scored a total of 252 points, which was, at the time of the recording, was the high score in New York State. The first 30 seconds of the match, which is what you're watching now, is called the autonomous period. During this time, the program is run using pre-programmed instructions. This means we are not currently controlling the robot, and it is only being run by what our programmers programmed it to do. Following this is a 1.5-minute driver controlled period. During this the two drivers, myself and Caitlin, drive around the field, collect rings, and try to throw them into the high goal. This year has been a challenge for us because of COVID. Only myself and Caitlin have been able to meet in person and actually physically work on the robot. We've had 2 qualifying competitions as well as 1 state competition in Vermont. At the state competition in Vermont, we won the Inspire Award, which is the highest award you can earn at any competition, and it gave us a spot at the World Championship this year. Unfortunately, due to COVID, this was canceled. So during this 1.5 minutes, we try to collect as many rings as possible and intake them into the robot and shoot them into the high goal. After this 1.5 minutes, there is a 30-second end game. During the end game, you can perform special tasks, for example, shooting the pins on the far left, or putting the wobble goals over the edge of the field on the opposite side of the goal. These tasks give you extra points, so you want to aim to try to do those. During the end game, the last 30 seconds, you are also allowed to continue to shoot rings into the high goal. To hit the pins, our programmers programmed a custom computer program that allows us to line up perfectly so we don't miss the pins when we shoot them. As Caitlin mentioned earlier, we have our arm that we use to grab the wobble goals and put them over the edge. Next, Caitlin will tell you what else we do for robotics outside of just building and programming.
So I have a question for you. True or false? An FTC team only builds and programs robots. I'll give you 5 seconds to make a guess. The right answer is false. Great job to everyone who made the correct guess. Yes, so far all we have shown you about being part of a robotics team is that we build and program robots. However, we do much more than that. As a robotics team, we also connect with and help our community. For example, this year we are great leads for the elderly in our community, presented at a local event and this was our last event before COVID shut everything down. And at this event, we encourage youth as well as adults to drive our robot around, create a virtual robot to help other teams, printed face shield bands for first responders in New York and for hospitals in Africa, and have communicated with and helped teams both in Vermont and internationally, including with the team in Libya. So now let's talk about how NASA uses robots. Do you know that NASA has made and continues to make dozens of robots to be sent up in space to complete tasks and home planets? For example, NASA, in conjunction with Canada, has built and programmed a huge robotic arm named Canadarm that moves large objects in space. Canadarm was first launched into space on November 13, 1981 on the Space Shuttle Columbia. Over the next 30 years that Canadarm was operational in space, it would make over 90 flights. As with everything in robotics, Canadarm went through many different versions to improve and add additional hardware mechanisms. There has been a total of 5 iterations. The 5 major different iterations of Canadarm were sent up with 5 different space shuttles. The first shuttle, as mentioned earlier, was Columbia. The second arm was launched on Challenger on April 4, 1983. Unfortunately, in January 1986, when Challenger was on one of its missions, there was a terrible accident and the shuttle exploded on the way up, losing not only the arm but the lives of 7 astronauts. The third shuttle launch was called Discovery. This shuttle took off on August 30, 1984. The fourth shuttle was launched on October 3, 1985. The name of this shuttle was Atlantis. The fifth and final space shuttle to hold Canadarm was Endeavour. Endeavour was launched on May 7, 1992. Canadarm got its name because it was built in Canada, and NASA wanted to recognize the people who worked on it. It was built with some of the toughest yet lightest materials possible to both withstand the elements of space and also to not add an outrageous amount of weight onto the space shuttle when it was launched. A lot of research, money, and time went into building and designing Canadarm. For example, a complete zero-gravity room had to be built just to test the arm, and that was on top of everything else needed to make the arm a success. Canadarm could lift over 66,000 pounds on Earth, which is just over 2.5 school buses. That is equivalent to almost 590,000 pounds, over 23.5 school buses in space. How much energy do you think Canadarm uses to have the ability to lift so much? Do you think it uses as much energy as A, a tea kettle, B, an air conditioner, C, a dryer, or D, a car? Talk among yourselves and pick the answer you think is correct. I'll give you around 20 seconds. The right answer is answer A, a tea kettle. Congratulations to everyone who guessed correctly. Throughout the arm's time in space, it completed many different tasks. Some of these include sending satellites into orbit, capturing satellites for repair. It also helped assemble the International Space Station. It supports astronauts during spacewalks. It has filmed the experience of astronauts in space with 2 IMAX cameras. And it inspects the shuttle's thermal protection system with the orbital room sensor system. To accomplish this, the arm is controlled by remote control, just like the controllers you have at home for your Xbox or PlayStation. And with the pre-programmed code, an astronaut can guide the arm to do exactly what is intended of it. Canadarm was one of the most known robotic mechanisms NASA used. However, in January 2011, the shuttle retired and the arm is no longer sent up to space. However, the arm's legacy lives on. It proved to help NASA much more than anyone first thought. It assisted in building the space station, which is used to help enhance the knowledge in space. It helped NASA with many tasks humans were unable to complete. Canadarm will be thanked and remembered by many for years to come. Alright, here's another question. How many rovers have traveled to Mars? Do you think it's A, 2, B, 4, C, 5, or D, 7? Again, I'll give you about 20 seconds to make your guess. And the answer is C, 5. Since July 4th, 1997, 5 rovers have been sent to Mars: Sojourner, Spirit, Opportunity, Curiosity, and Perseverance. First, Isabella will tell you about Curiosity.
Curiosity is a car-sized rover sent to Mars to study the planet and determine if Mars is sustainable for life. Curiosity is a part of NASA's Mars Science Laboratory mission, or the MSL, and launched in November 26 in 2011 and landed on Mars August 5, 2012. That's almost a year. Curiosity is still exploring Mars to this day. Here's a look at Curiosity and the different parts of it. What's the purpose of Curiosity? Well, the main purpose of that MSL mission, known as Curiosity, was to determine if humans could ever live on Mars. Curiosity still had other tasks. Studying the climate and geology of Mars and planning human mission to Mars are just some of them. Ever since Curiosity has been on Mars, it has made some crazy discoveries. For example, there might have been ancient water on ancient Mars. Smooth and rounded rocks found by Curiosity left scientists shook. They believe these rocks are shaped by water flow and knee deep. Now it's time for fun facts about Curiosity. Did you know Curiosity is the biggest rover to ever be sent to Mars? It weighs 1,982 pounds and is over 7 feet tall. Let's test your knowledge on Curiosity. Here's a question. How many cameras does Curiosity have? Is it A, 2, B, 13, C, 17, or D, 9? I will give you guys 20 seconds to find your answer. The correct answer is 17, which is actually the most of any NASA planetary mission. Congratulations to everyone who got it. Here's another question. How long has Curiosity been on Mars? Is it A, 2 years and 134 days, B, 8 years and about 240 days, C, 12 years and 347 days, or D, 7 years and about 91 days? I will give you guys 20 seconds to think. Good luck. The correct answer is B, 8 years and about 240 days. Congratulations to everyone who got it. Now Chris will introduce you to Perseverance.
Now time for some fun facts about space. Did you know the highest mountain we know of is on an asteroid named Vesta? It is 3 times the size of Mount Everest. That is 13 miles tall and 112 miles wide. Now, that's cool. Did you know approximately 1 million Earths can fit in the sun? But the sun is considered a medium-sized star. That sun is so big, the mass takes up 99.86% of the Milky Way. And finally, our last fact. Did you know there are more stars in space than there are grains of sand on every beach on Earth? That's more than billions of trillions of stars. Perseverance, also known as Percy, is a current rover that NASA has landed on Mars for scientific purposes. Percy was launched into space on July 30th, 2020, and landed February 18th, 2021, in the Jezero crater. The main purpose of Percy is to seek for signs of ancient life and collect samples of rock for possible return to Earth. Perseverance has a similar design to its predecessor rover, Curiosity, which Isabella just talked about. Percy carries 7 primary payload instruments, 19 cameras, and 2 microphones. The rover also carries a mini helicopter, Ingenuity, an experimental aircraft and technology showcase that made the first powered flight on another planet. The Mars helicopter, Ingenuity, is a technology demonstration to test powered, controlled flight on another world for the first time. Once Percy reached a suitable airfield location, it released Ingenuity into the surface so it could perform a series of test flights over a 30 Martian day experimental window. This is a 360-degree panorama view of the crater which Percy was using one of Percy's many cameras. Percy has many test tubes which it uses to put samples of rocks and minerals in, and then drops them on the ground for another robot to pick up. NASA is currently in the process of building the rover designed to pick up these test tubes and safely bring the samples back to Earth for more testing. Let's test your memory. What's the name of the first helicopter to fly around the world, to fly on another world? Is it A, Perseverance, B, Ingenuity, C, Curiosity, or D, Atlantis? I'll give you around 10 seconds to come up with your answer. The right answer is B, Ingenuity. Congratulations to everyone who got it.
So robotics is paving the path for humans on Mars. To be able to better discover if humans can visit and eventually live on Mars, we need to know if life ever existed on Mars, and if it did, what happened? This is where robotics comes into play. While on Mars, Perseverance is searching for signs of life of ancient microorganisms by taking rock samples and sending them to a lab for evaluation. Also, as far as we know, water must be present for life. That said, if life ever was present on Mars, it is very likely that there was some kind of water supply. The rovers are looking around the planet and taking samples of the ground to see if water is or was present. Eventually, robot spacecrafts, rovers, and drills could be used to access water resources before and even during human exploration. Additionally, robots are testing what the radiation environment is like on Mars to further see if life ever existed. When do you think NASA plans on sending humans to Mars? A. 2022, B. 2030, C. 2040, or D. 2050? Again, I'll give you about 20 seconds to come up with your answer. The correct answer is B. 2030. Awesome job, everyone who guessed correctly. Wow, can you believe that in less than 20 years, humans might be on Mars? And we have robotics to thank for that. Robotic exploration will pave the path for future human exploration of Mars. With the help of robotics and continuously learning more about Mars and space, sending humans to Mars is something NASA plans on doing within the next decade. And hopefully you'll be following their journey and knowing that robotics is what allowed humans to step foot on Mars. Do you know that you can join and become part of an FTC team? If you live near Plattsburgh, then come join Team Beta. We'd love to have you as part of our team. You can contact our coach at tamnewith@yahoo.com, which I will put in the chat so your teachers can have access to it and help you get in contact with our team. We would love for you to see more about what we do and to help us stay a successful team. However, if you don't live near Plattsburgh, that is not a problem. There are hundreds of teams all across New York State. To find one local to you, you should visit firstinspires.org or go to your local 4-H directors to get you in contact with a local robotics team. There are many amazing teams that will be lucky to have you. Although there are hundreds of teams, there might not be one where you live or where you go to school, especially if you're in a more rural and remote area. If this is the case, you should think about starting an FTC team at your school. You can talk to your school officials and contact our team at our coach's email, and we'd love to help you get started in your journey to becoming a FIRST Robotics team. Thank you for listening, and I hope you enjoyed it, and we are happy to answer any questions that you have for the time we have left.
All right, if we don't have any questions in the chat, we are all set. All right, I'm not seeing any. Just a lot of thank yous.